Support of a function. Definition of support of a function. Let phi be an open set in Rn. Let phi be a real or complex valued function defined on omega. Then the support of phi is defined by, it is denoted by SUPP, support of phi, and it is the closure of the set of all x belongs to omega such that phi of x is not equals to 0, and we can write closure in notation. That means closure of, and we can read as closure of the set of all x belongs to phi such that phi of x is not equals to 0. So what does it mean? It means the support of phi is the closure of the set on which phi is non-zero. And it is the support of phi means the closure of the set on which the function phi is non-zero. And from definition, the support of phi is always closed because it is the closure of some set, and closure of some set is always closed. Closure is always closed. Now we are going to discuss about the example, some example of support of phi. Examples: consider a function phi from R to R defined by phi of x is equals to 1 for x greater than 0 and 0 for x less than or equals to 0. Therefore, by definition of support of phi, we can write, as we have already discussed about the definition of support of phi, it is the set of all x in R such that phi of x is not equals to 0 and closure, and which can be written as x belongs to R such that x is greater than 0, closure. Because by definition we have to take the function which is not equals to 0, and this is the stepwise function, and for x less than or equals to 0 we have value 0, so we don't take this value, because by definition of support of phi we should take always those values of phi which does not take the value 0. So we have to take for x greater than 0, because in this domain the phi is not equals to 0. So it is the closure of the set x belongs to R such that x is greater than 0 and it means the set, this set means x belongs to R such that x is greater than 0. It means that we have to take the value greater than 0 to infinity, but we have closure also, and its closure is always closure of 0 to infinity is, we should include 0 also and to the infinity, so it gives 0 to infinity. So we have calculated the value of support of phi from this example. I think it is clear.